Hello everyone. Today we will see Snowflake stream and task in action. We would quickly go through what is stream and task and we'll see how does it really work. Before we start the tutorial, you can go to the comment box and refer the URL for the entire tutorial which is available in the website. You can also see the SQL script which is being referred for this in action practice. So who is this tutorial for? If you know what is a stream and task is and want to see how it works in action, then this tutorial is for you. If you want to build a solid understanding of when to use a stream and task and its limitation, then this tutorial is for you. If you want to design a CDC or a Delta ingestion patterns using stream and task and track insert only or insert, delete, update kind of changes like a pro, then this tutorial is for you. A stream ensures exactly one semantics for a new and the change data in a table. And if you want to understand how, then this tutorial is for you. So let's start. Let's go to a little bit of theory. All about a stream. A stream object records and capture data manipulation language changes made to a table, which include insert, update, and delete, as well as a metadata about each changes. So that action can be taken using the change data. This process is referred as a change data capture. An individual table stream tracks the changes made to a rows in a source table. A table stream, also referred to as simply as stream, makes a change table available of what change at a row level between two transactional points of time in a table. This allows querying and consuming a sequence of changes record in a transactional fashion. Let's talk about a task. A Snowflake task is also referred to as simply a task is such an object that can schedule an SQL statement to be automatically executed as a recurring event. A task can execute a single SQL statement, including call to a store procedure. There is no event source that can trigger a task. Instead, a task runs on a schedule. A task can have a multiple task as its offspring, which we call task tree. However, it is little different from the DAG. It is not exactly a DAG. In a DAG, you can fork and a join, but in a task tree, you can fork, but you cannot join. You can refer the picture. So this is a brief theory about what is a stream and what is task. Now for our in-action hands-on practice, let's understand how the data flow model, because that would help you to visualize how the data is flowing and how the stream and task really work in action. As we all know, the leftmost side represents the source of data, and the data may come as a Delta record or a CDC. Then in case of Snowflake, which is a native cloud data warehouse, the landing zone must be S3 or Azure Blob ADLS Gen 2, or it could be a Google bucket storage. Then finally data reaches to the Snowflake environment. The first layer, which generally people call a raw layer or a stage layer. Then the data flows further towards a curated layer. And then finally the data is available for the consumption layer. This is primarily three logical layers. People may call it bronze, silver, and gold and all those things. So a data, the CDC part, which starts from the source, then the same CDC lands to the landing zone, and from the landing zone, that Delta part reaches to the raw, and then it further moves towards the curated, and finally it reaches to the consumption layer. So this is how the overall CDC works. Now the next CDC, and it also flows the same path. So it starts from the source, goes to the landing zone, raw, curated, and consumption. So that is how the overall Delta data flows, starting from the point where it generated till the consumption. And this is how we can see the data flow from point of generation towards a point of consumption. And when we talk about a CDC, the two key requirement which most of the project prefer to apply is that only once and as soon as possible. And this as soon as possible varies from real-time analytics to the micro batches, and sometimes you can say that I would process it twice a day or thrice a day. So now let's understand where exactly the stream and task come when we talk about the Snowflake. If you look into this red demarcation, this is where Snowflake does not have any control. So stream and task actually starts within the Snowflake environment, which is your either raw, curated, or a consumption. So when you see this screen boundary where your task and stream should reside, and you have all the control over the stream and task. So this is about the scope of stream and task within the Snowflake environment, and when we are talking about CDC or a Delta ingestion pattern. So now let's move and understand how stream is really able to capture that change data. So this is our picture, right? You have this delta arriving from source to landing zone, and from landing zone, it would reach to the layer. Let's enlarge this table. So what happens when you create a stream? Okay, that stream actually adds 3 additional columns to the existing table. However, when you try to describe the existing table, those 3 columns would not be visible. But when you do a select star from the stream, which is created on the table, you can really see the total number of columns which is already there on the existing table, plus there are 3 additional columns. What is these columns are named? The first column called metadata action, which records whether it's an insert or a delete. The second column talks about metadata is update. So if the insert has happened, whether this insert is an update or a insert. And the third is a row ID. So every change which is being recorded by the stream is having a hash key, and that hash key is maintained in this column. Now you may ask, if everything is being stored in the existing table, then what does the stream object contain? The stream object contains only the offset. The stream will only hold the offset that from here the changes are there in the table. So now let's say that you are going to get a new data set. So you got another CDC in your source that reaches somehow to the landing zone, and finally that reaches to your raw layer. As soon as that reaches to the raw layer, your stream also captures that additional information has come. And if you have already consumed through the transaction your earlier stream dataset, the offset will move to the new position and tell you that this is a new CDC. So this is how the overall CDC or a delta ingestion work in streams. So now let's see everything is in action. So I have divided this entire hands-on practice in total 6 chapters. Okay, and logically we have seen that what we are going to do. For a simplicity, I will just keep 3 layers. The first layer is called a layer where the data would mimic that it is coming from some external system. And the layer 1, which will have primarily your sales data, okay, and we will create a stream object on the top of this sales data, and we'll also create a task object which will consume data from this stream and finally fed the data to the consumption layer. So the first layer, this is the layer 0, which will have your sales table, which we are giving a name called sales external table, which may represent a S3 bucket and all those things. It will also have a file format, because any data which is in the external table need a file format for its to convert it into appropriate tabular format. We also need to have a stage object where your data will be stored. We will load the data to the stage via SnowSQL. We can also do through the UI, but I just want to show how does it work through the SnowSQL. We will use a copy command to load the data. So the layer 0 is nothing but simply mimicking your external dataset or external storage. And for this, we are using a context DemoDB and public schema, and we are using a compute warehouse. When we go to the layer 1, which is primarily our stage layer where your data would land, or you would really create an external table, in this you will have a name called sales raw table. This we will create an stream object. We will also have a task object, and then it will also have the same context. For a simplicity, all the contexts are same. However, in production environment or in UAT, in your real project, this context might be different. People may have a separate context for each logical layers. Once the data is there on your stream, that the data will go inside the sales consumption layer, and we just need to have a sequence object for tracking how many rows are there. We also have a common layer, which we call where we will have the product master table, just to use the join between layer 1 and common layer to produce the sales consumption layer. So let's start creating an external table. So the first step that I am doing it is primarily setting the context. As you know, context is a very important thing in Snowflake, so you just have to set the context. Now we can see our context is set here. Okay, so we have using a system admin, compute warehouse, DemoDB, and the public schema. Now the first one, I am specifically giving the context in all the cases just to make sure that you are not confused with that. So first, I'm going to mimic the external table, and I'm going to create a sales table, and I'm having an extension called sales_ext, which is nothing but an external table. This table has a product ID as a first column, purchase date as a second column, zip as a third column, units as a fourth column, and revenue as a fifth column. Since this is coming as a stage, I am not giving any specific data type. So let me create this table. I created the table, and let me describe the table for you. So as you can see, I have a product ID. Everything is in a varchar. As you know, the string internally converted into the varchar, and if you have not specified any size, then it will take the default size of 16 MB. The next step is step 3. Here we will create a stage data. So I'm creating a stage object which is known as sales external stage. Okay, and this is my internal stage. I'm not creating an external stage for simplicity. So I ran this command, and this stage is also created successfully for me. Let me show you. Okay, now let's describe this object. So here I'm describing stage and the name of the object. So you can see this entire description of this stage object. Okay, let's see whether this stage object is having any data set or not. So no, it doesn't have any data set. Okay, now when we load our data to the stage object and try to use a copy command, the copy command expects a file format. By default, it is a CSV. So let's create the file format. So here when you see that I'm using a type CSV, compression auto, record delimiter is 1. And I'm just skipping the header. Rest of the things are optional. And I ran that, and this is created successfully. Now let's describe the file format quickly. So this is demo public CSV file format, and it shows that CSV and the record delimiter is new line character. Okay, let me load the data using SnowSQL. So here I have two data set. One is a sales data set, which has a product ID, date, zip, units, and revenue. And I have another product master, which is nothing but for product ID. It creates the entire dimension detail, which is product name, product category, segment, manufacturer ID, and the manufacturers. So here you can see that for each product, what the sale has happened, in which zip code, what is the unit, and what is the revenue, and on the date. So this two data set, we are going to use it for this example. So now I'm going to use the SnowSQL for loading the data. So this is a command where you can see that I start with SnowSQL. I give -a for the account, which includes your account ID, followed by in which region you have set up the account, and then the cloud provider, followed by your username, followed by your role, and followed by your database name, and followed by your schema. You can also skip the roles, database, and schema. However, I prefer to use that one because I know for this demo, I'm using system admin as a role, DemoDB as a database, and public as a schema. Now, the moment you press an enter, it will ask for a password. So as soon as I enter my password, now it says that you logged in as a user 01. Your warehouse, which is going to be used as a part of this session, is a compute warehouse. You are using this DemoDB and public as a context. You can just check and see whether you have any tables or anything available over here or not. Sure. So I don't have any tables, perfectly fine. So I just clean the screen for you. Since I have already executed this command, I would just use arrow sign, and I'm trying to load the sales data. So the moment I press enter, so as you see that I'm loading the sales data, So you see that one, the sales data, the source of the sales data is sales CSV, and the target is sales CSV.gzip. By default, Snowflake compress the file and encrypt it when it is loaded the data into the stage environment. The total size of the file is 70707K, and the target size, you can see that it has already compressed. Okay, there is no source compression. Target compression is gzip, which you prefer to change if you want to do that, and it is already uploaded. Okay, now let me list. So the data is loaded. Now we would like to know whether the data is loaded properly or not. Okay, for that I will go back to my Snowflake UI. Okay, so this is the command which you can try that out. Now let's list it down whether it is loaded or not properly. So you can see that one, this data set is loaded, and it also has an MD5 check. Now let's see. So if you have to, this is the query which you can use to query the external table, right? My data is loaded into the sales stage environment. Okay, if I have to really query it, I would do this query, and this will show me the data set. Make sure that it is a case sensitive, so you have that. So now you see all the data set is available, and it has total 20,000 rows. So I write it here. It's perfectly fine. Now, once the data is available in your stage environment, you need to make sure that you populate this data into the sales external table. We know the sales external table is, we are mimicking the table. So let me see if there is any data set or not. So it doesn't have any data, 0 record. Now I'm going to use a copy command. Let's understand the construct of a copy command. So it says copy into, I am copying into the external sales table, and from this location, right? And I'm going to make a minor changes because I loaded that earlier. And while loading the data from the stage, it has to use the file format, the CSV file format, and this object is also available under DemoDB public. Now I selected this statement and ran the command, and it may take a while. Okay, and it says that 20,000 rows passed, 20,000 rows loaded, and no error seen. Okay, let's perform this check. So I saw that 20,000 records are loaded, and let's see whether these records are really matching to the data set. So you see that one, product ID 833, this one, all those things, right? So this completes our chapter 2. And if I really want to understand that how the data looks like, so this is important for us. So we see that data is available for 2000 and 2004, 2003, and all those things. So we will see when we are going to use the delta, we are trying to use this purchase date as a delta, and we'll try to load the delta automatically to your consumption layer or your curated layer, right? So let's move to the next chapter. So before we get into the curation layer and streaming task, I would prefer to load the master data, and this time my loading would happen through the Snowflake UI rather than SnowSQL CLI feature. So I'm jumping to the new worksheet, and before I really run any other command, I try to set up the context for this worksheet. And as you know that every time you open a new worksheet, either it will take a default preferences from your profile, or you have to explicitly set the context. Okay, so as a part of this thing, so now we see that one, we will try to refresh that one. We already have this DemoDB. In this DemoDB, we have a sales table which represent an external table. Now let's run this DDL command. This is primarily creating a sales raw, which is nothing but a stage data. And in real world, this would be the first table where data would be staged through the external data set, or you load it manually. Okay, let's refresh it. And you see that when I have product master, okay, which is nothing but product ID, product description, category, segment, manufacturer ID, and manufacturer name. Okay. I'm going to run this command just to show you that it doesn't have any data set. Perfectly fine. It doesn't have any data set. Now I will go to the database icon. And here it is already selected. I would say load data and click on the load data. And it will by default use the compute warehouse because that is the only warehouse right now running for me. I click on the next button. I selected the file from my, and you can see that product_master CSV I have selected. I go to the next one. Okay, I already have a CSV file format. If you have a lot of file format, probably you would prefer to choose which one you want to use it. I click on the next, and then it says do not load any data in the file. In case of a failure, when it encounters an error in the external dataset, what is the action you want to prefer? Okay, so right now I'm saying stop loading, roll back, and return the error, right? So this is what I'm going to do that one. I ran this one and the data is loaded. Okay, so there is no problem in the data file, and it says that 2412 records are loaded. Okay, I close it. See that one, how many records it has it. So if you see that one, it has 24. So all the records are kind of loaded. Pretty good. Okay, now revalidate this data set. How does it look like? If you come to this worksheet, chapter 2 worksheet, and you ran the command, this one, it also says that, since I have ran the limited query, if I click here, if I preview data, okay, I probably have to refresh it. And then you can see that one. So this is another mechanism you can refer how many records are there. So what chapter 4 does? The chapter 4 will primarily create a sales table under the raw layer, and we will load the history data, and it will also create a sales table in a consumption layer, and we will load all the data which is available, the 20K record which is available in the external table. Okay, so first, as I always do, I set up my context. Once my context is set up, automatically you can see all the data set here. Right now I have just 2 tables. Okay, so here I'm going to create a sales table under the raw layer. Okay, and it would not look very different for a simplicity. We will keep the same data structure. However, what we have done it here, we have given a specific data type for each of them. Okay, okay, so now if I try to refresh that one, here you can see that I have this sales data under the raw, and it doesn't have anything. All those data types are there. Now what I'm going to do to insert the data. So what we have seen here, right? What we have seen here, that we have seen the data is available from 2000 until 2004, right? Okay. So here I would say I ran this one. Okay, so you can see that one. I would just remove that and I would run this one. Okay, so first we are going to load all the data set from 2000, which is roughly around 15 or 15K, and then we will load the rest of the data set as a delta for practice, right? Okay, so I'm going to write an insert select query. Okay, here I'm going to load the data from 2000 January 15, 2000 January 19, and 2015 February. Okay, and I ran this query, and data is inserted into the table. I refresh the data set here, and you can see the data is available in the sales data. So 15,744 record. Okay, so 15,744 record out of 20,000 record. So what is our next step? Okay, we are going to create a consumption table. So as we have seen here, so we created this sales table under the raw layer, and I'm going to create a sales table under the consumption layer. So before I create the consumption layer table, okay, I'm going to create a sequence object, okay, which will auto-generate a number for you as a primary key or a surrogate key. So I ran this, and the name of the sequence I have given a sales sequence. Then I'm going to create a table called sales, which is under the consumption. And here I am using this transaction key or surrogate key, or you can change it with a PK also. Okay, and it has few additional columns compared to this one. It will have a product ID, product descriptions, category, segment, manufacturing, purchase, and all those stuff, right? Okay, so I am running this query, and this DDL will create a new table under our. Okay, so you can see that one, and you see it has no record, right? Okay, now if you already have something, you can delete using this command, but I'm going to load the data here using a join query. So what it does, this is I'm inserting a record into the sales data, which logically in the consumption layer. Okay, and I'm giving a specific column names because I have auto-generated key over there. Okay, here I am selecting by joining two tables, the raw table and the product master table, right? And I am doing it on the basis of product ID, right? And so rest of the things looks pretty straightforward. So here you can see that one, and I am running this query, and it would insert around 15,774 record, right? Okay, let's do the count and revalidate that from the SQL, and also refresh this left panel to check whether the data summary is showing. Okay, so you can see that one, and the data is coming. So here I have all the data set, so perfectly fine. Okay, so now here I end my chapter 4. So we have covered the entire layer 0 generation. We have covered the common data population. We have covered generating sales data and the sales consumption layer. So all those things are done. Now we will jump into the stream, how the really stream works, and we will demonstrate you. So let's go to the chapter 5, which is primarily talking about stream. Sometimes Snowflake takes time to load the script. Make sure that you keep a copy of your script somewhere else too, even though you may not lose it anytime, but it is better to have it in your Git repository or any kind of repository. So what we'll cover in this chapter will primarily create a stream on the sales raw table. So if we look into the introduction, right, this is a table which is primarily mimicking your external storage like ADLS Gen 2 or S3 bucket or Google bucket. The delta would come into the raw layer. So when you see that one, if you look into this image, your raw layer will have that CDC coming as a first entry point for Snowflake, and your stream would sit on the top of that, and you would consume the stream to populate either your curated layer or a consumption layer. For the simplicity, I have really removed the curated layer. I am just keeping it the consumption layer directly. So in the chapter 5, we are again setting our context as a first task. We will see how many record I have it into my, this is called 15744. Okay. Now I'm going to create a stream, and let's understand the construct of this stream SQL. So you can say create or replace stream. You have to give a name of the stream as just a name of the stream or a fully qualified name for this one. Right now I'm creating a stream object within the DemoDB and public schema. On table, so I also have to give a fully qualified name and identifier that I'm creating this stream on this sales raw table. Now let me run this, or I can also say, so you see right now I do not have any stream running on my environment. So you can see that no stream is running. So you can see that no stream is running in my environment. So now I'm going to create this stream. So this got executed. I have given the name called sales raw stream because this is associated with a table called sales raw. You can follow any naming convention for your streams. Now next is that I'm running this show stream. So I got a stream, and this says the name of the stream is a sales raw stream. It is available on the DemoDB, and it is part of the public schema. And who is the owner? The owner of this particular stream is a system admin, and the comment and everything, right? And on which table this stream is created, and that is an important thing. Okay, and this is called table name, and the type of stream is a delta. Okay, and all those things. So we'll not go into much detail about any other things. Now, right now I have not populated any additional data after I have created a stream. So if you go and perform a statement or select a star from the raw stream, it will just show empty things. Now, interesting thing to notice here: product ID, purchase date, zip, units, revenue, and then, as I told you, there are 3 additional meta columns that is called action, is update, and row ID that we have seen each here. So we have this action and all those things. And if you see how this raw table looks like, so raw table will not populate this thing. So it has a data, okay. However, the stream does not have a data, and stream, when you perform this select star from the stream, it actually runs the select statement on the existing table, and these columns are applicable only when you fire a select statement on the stream. Important thing to remember. What I'm going to do, I'm going to insert these values one by one the query. So I think there is an empty statement, so let's leave that one. So now if I go and do this one, instead of I will just do a count, or I can simply go from the left side and I can say DMDB, and here I go to the public. Here I click on the raw layer where I have inserted 10 additional. I can see that. Okay, now let's do this count here again, run. So I got 17. However, if I do to the consumption layer, which is exactly the same number of, it has 744. So let me insert 10 records as a sample record to show you how the stream works. If you look into this 10 record, I have kept 101 to 200. Okay, these are the sample things. Dates are like 2020, and just to make sure that how the zip code works, it is like starting from 1 to 10. Okay, so we specifically know which record to update or which record to delete for our use case, and I have given some prices. As a part of this, what would I do? I will primarily update this record, and I will primarily delete this record, and we will see how does it work. Okay, so I already have 15744 plus 10 records. Okay, we'll see that one. Now, if I try to do a select operation on the stream, which only captures the delta from the time it has created, so I can run that. So when I run that, what it shows, and this is very interesting, it shows exactly the 10 records. Okay, and these 10 records look like this, and these all operations are insert, not update. And when I say insert, this record is also telling that insert has happened on the stream because the stream has captured those changes, and is update is a false in the sense it is not an update statement. If it is insert and update statement is a true in the sense it is an update statement, and you will find 2 records per update. You can also make it delete, and then you can run it. You would not get any record because there is no record with metadata action delete. But if you make it insert, it is case sensitive. Okay, so you can see that 110 record has come. So as long as you are not consuming the stream, the data would always be available for a select. The moment you put it for any other DML operation, you primarily consume the data set, and we will show it in the next part. Now, what we are going to do, since when we populated data set, what we have done, so we have seen how the insert work. Now let's operate on update and delete. And before I perform update and delete, I would like to consume the raw data into the consumption set. So I already have the query. So I go to my previous chapters, and here I just take the data set from here. Okay, and I come here and I copy paste. And one more thing, I would like to change it. This is raw, so this should be stream because I'm consuming from a stream. So I consume all the data set from my stream, and let me see that. Yeah, okay, so I have total 10 record, and I'm going to insert the data from the stream. Okay, and now when I go back to my stream, since I have consumed my delta into a consumption layer, actually I do not have anything, right? So now we are ready to start with update operation and delete operation. For update operation, I would first go and update a record which has a zip code 005, and I would make a purchase date is like 015. And if I try to show you the example, this one is primarily, this records, I'm going to update it. Okay, here you see that one, it is a date 25, 26, 27, and I'm going to update this date. Okay, so I am updating this date, and the moment I run this query, my stream again gets a change. And when I go and perform this data set, I say, yeah, so the change has happened here. So you see that one, an interesting one. When I do this update, here it says insert is true and delete is true, and they are part of the same data set. Okay, and if you really want to understand what has been changed between these two record, so delete says that the record which was previously held by the table, and the update says, and here the purpose of the metadata comes into the picture, right? Okay, so here if you see this metadata, it is starting with 76B 3D and ending with 367. Here also it is 367 and the 76B 3D. So if you use this metadata, you would come to know, you can really compare and write a complex logic for CDC. Now, what happens if I try to update two dataset, which is I'm working on the zip 6, and if I update this two dataset, right? Okay, and again, let's go back to the stream and see how the stream is working. So you see that one, this 66 and 66 here, okay, and the delete is representing the previous data set, and the new record is primarily this one where you have insert. Okay, if I give this to 77, okay, let's say what happens. You don't see additional record, because since I have not yet consumed the stream, okay, what it is capturing, it is capturing from the last changes to the current changes. And that is an important thing. When you are trying to apply a CDC and you are having a lot of intermediate changes, and if your stream has not yet triggered, obviously you would lose those intermediate changes. So make sure that you understand the CDC very appropriately. Now let's perform some delete operation, right? And I'm going to delete the 8 and 9 and 10. Okay, so you see that one, the last three record we have kept is 8, 9, 10 as a delete record. So I'm going to delete as a one single statement. Okay, and it's a pretty straightforward. So I deleted 3 record. Okay, and now I am going to run the stream. So I already have a 4 record into my stream table which captures the last 2 updates. Now I am running this. Okay, now you see that one, these 3 records are deleted, right? So they do not exist into the table, but they still exist into the stream unless you really consume that data set, right? Okay, I can really rerun this data set. I can rerun up to here because I'm anyhow running into the stream. And once I do this insert, what would happen, the 7 rows are consumed. So you really have to be very, very careful while performing a merge operation or insert operation, and use this meta action checksum as well as is update flag to have a proper data set to be moved from your curated layer or raw layer to the consumption layer. Right now, if I try to see this, and you can see that the stream is fully empty. Okay, let's perform another things. Okay, if I'm making a changes to the same thing 3 times, what we have already seen, that one, this 3 different statement, let's see what happens. So 1007 is let's see how the 1007 looks like first. Okay, so 1007 is like product ID is 177 and the unit is this one, and here I'm changing the date first to 27. Okay, so I'm making it 07, or maybe I will making it 09, and then I'm making it 07, then I'm making it 27 back. Okay, so if I do that one, 3 statement running one after another. Okay, and these are the update statements. So logically pause the screen and think. Let's run the stream. So the stream doesn't have, because there is no changes at all, right? However, if I run this 9, 10, 11, now my changes are done, and when I go back to the stream and run it again, now you see that one, right? So this is a change, and this is an interesting thing. So sometimes you are actually simply updating, but you are just updating something, right? So this is how the stream really works with insert, update, and delete. Insert is a pretty straightforward. You will get 1 row at a time. Update, you will get always 2 record from the previous thing, still your stream is consumed. And for delete, you will also get 1 record. So here I end this chapter. So let's go to the chapter 6. Chapter 6, what we'll do. So what we have seen, how the stream behaves and what is how it looks like from insert, update and delete operations, and how to really capture those changes and how do you consume it into stream. If the stream is not yet consumed, how the update operation performs. Now what we'll do, we'll create a stream object and we'll really push the data from sales raw table to the sales consumption table. Okay, so here I first set the context. Here we are going to create a stream again called sales raw stream, same one what we have seen in the chapter 5. However, we will apply a flag called append only true. Okay, because we are dealing with the incoming records and it is only being appended. And just run that one. Okay, let me describe it. I described that perfectly fine. You can see that one insert only comment has come. Now what I'm going to do, if you go back to our load here, what we have seen that 2003 has roughly 1620 and 588, maybe 2200 records are there, and I'm going to consume these records through the stream, right? Okay, so I am going to, first of all, let me select these things. Okay, where I'm selecting it, I'm selecting it from the external table. Okay, and it gives me around 2208 record, right? So now let me run this insert as a select statement. It will insert the data into the sales table under the raw context, and it will pick the data from the sales table, which is in the external context, and it will pick the data from 2003 dataset. We see 2208 records inserted. Let's refresh and see whether it is reflecting there or not. So we inserted data into the sales raw table. Let's see the sales raw table. And we have 17,952 records. Makes sense? Let's perform this operation. Now, when we try to, let's run the select statement on the stream object. Since we have just inserted 2208 record into sales raw table, if we perform this select operation on the raw stream, it would show that 2208 record as an insert operation on the data. So you can see that one. This is exactly the same set of data, and the number of rows which are being tracked is 2208, and all the actions are insert and they are not updated, so it is standing false, and the row ID. Now how can I insert this data to the consumption table? So this is an insert operation on the consumption table, and this is as a select statement. Only difference here, you see that one, instead of selecting from the sales raw table, we are selecting from sales raw stream, which has only the delta data available. So let's run that statement, and it also shows that 2208 record inserted. Okay, now since this operation has consumed data from the stream should have 0 record, right? Perfectly, stream doesn't have any record. Now the data in the cells under the consumption context should have exactly the same number of record as raw table, and I can see that one, it is having a 17,952 records. Perfectly fine. So here what we have discovered, that the data which is being inserted into the sales raw context is being tracked into the sales raw stream, and using this insert statement, a single statement, you can push the data from the stream to the consumption layer. And we end our chapter 6 here. So this is our last chapter, which will create a task, and this task will automatically consume data from the stream on a schedule basis. So let's go back to the introduction. Here what we are trying to do, we are trying to populate the data into the sales consumption table via a task object. The task object is in the context of layer 1, and the consumption, which is a target object, is in the layer 2. So first select our context. So now we can see system admin, compute warehouse, and all those things are done perfectly fine. So step 2, we are going to create a task object. And as we have seen in the theory, task object is nothing but it runs a single SQL statement, or it can call a single stored procedure, and it need to be triggered on a schedule basis. You can either use a cron style of scheduling, or you can simply give minutes. So in this task, we say create or replace task, fully qualified name. And we also want to tell this task that use a compute warehouse. You can give your choice of warehouse. So it would run every minute. And what it would trigger? It would trigger only if the stream has a data. In the sense, if this stream, which is a stream sitting on the sales table, sales raw table, it will trigger only if this has a data. So this is a condition which we have set up. And what it would run exactly the same statement what we had executed in the previous chapter, right? So let me run this create task. Now the task is created successfully. We can see that one. Let's describe the task and see how does it look like. So here I describe the task. The name of the task is a sales task. It has a unique ID. It is sitting, or this object belongs to database DemoDB public schema. Owner is system admin, and it uses the compute warehouse as a compute engine, and it is scheduled for 1 minute. It doesn't have any dependency. And right now the state of the task is suspended, and you can also see what it is doing. It is primarily executing this single SQL statement. Now, when the task is created, by default, task is in the suspended state, and you have to resume the task to make it active. And you can use an alter command like alter task, the fully qualified name of the task, and then you say resume. Now, one important thing is there. If you have not given a execute task grant to the system role, this statement will fail. So make sure that you run this command and then you come back and use this alter command. So now I am resuming the task. Now my task is resumed. Let me describe it once again. And now if I see, the task has a status called started. Perfectly fine. Now, how do you know whether my task is really running or not? Okay, so this is I'm hitting a query on the information schema task history, and here I can see whether my task is running or not. So since I have tried a lot of tasks, all the task is coming. You can really filter the task based on the state. Okay, so there will be only one task which is scheduled. I can scroll down further. Okay, so you can see that this task is a schedule. Okay, now my task, I have created a task, I have activated a task, and I know this task is kind of a constantly running, and it would invoke as soon as there is a data into the stream object. So now I'm going to insert a record for 2000. So now I'm going to insert data set, which is around 1978 from this date. And first let me select this. So I selected that. So I have around 1978 rows. And this data is going to be inserted into the raw table where my stream is sitting. So I simply perform this insert operation. Now my insert is done successfully on sales raw table. Now let me see the select count. So as we know, so the number of record has increased from 17,000 to 19,000. And let me see how much record do I have as a CDC. So sales raw stream has captured all the 1978 records. Okay, and let me see the consumption layer sales table. Consumption layer sales table is still sitting in 17,1952, right? Let me see, now my task should automatically consume it. So I have added a filter this. Okay, so it looks like it has consumed it, or it is kind of a consuming it. Okay, so it says that state is succeeded, right? Okay, so there is a one which is kind of a succeeded here. Okay, and I can so I can see that one, there is an insert query which got executed. So this is how. Okay, so you can see that one, this task has been executed now, right? If I run this query, I should see somewhere around 19,000 rows, right? Perfectly fine, 19,930 rows. Let me pick the date 11 here, and I go back to my last chapter, and I put this date here again. Okay, 11. Let me first run this select statement and see how much record does it come. So I have roughly 70 records. Okay, and this 70 record when matches, it will turn into exactly 20K, right? I am performing an insert operation once again, and now my insert operation has 70 additional records. Let me check. So I have total 20,000 record. My CDC dataset looks, yes, I have exactly 70 record, and my consumption sales data on the consumption layer is still 19,000. Now, since I have already inserted, let me see how does it look like, whether any succeed has happened today. I should be able to see 2. Let me run that. I'm constantly, now you can see that when I got 2 succeed, in the sense second stream or second CDC also perform well, and I can see 20,000 record. Let me refresh this. So now I see that starting from my data source, okay, my first layer raw has a 20,000 record, my consumption layer has a 20,000 record. So this is how the CDC works. You can really use stream and task to build a complete complex ETL pipeline. So we have pretty much covered how to ingest data as a one-time, how to ingest data through the CDC using stream, how to load the data from layer 1 to layer 2 through the task, how to enable the task, how to track the task, right? And at the end, you generally prefer to drop all those things. So you can simply run like drop task, you can really run drop stream, you can really run this drop table statement to make sure that your environment is neat and clean. So thanks for watching this stream and task in action tutorial, and I hope that you would find this tutorial valuable. I have also created a lot of videos for Snowflake tools as well as Snowflake certification. You can go and you can subscribe my channel. If you have any specific comment and observation, feel free to share through the comment box.